Here's problem B from 2007, form B, and it's a graph problem. That is a graph of f prime from -5 to 5 with f1 equals 3. And for A, for -5 to 5, find all values of x at which f, which is integral of f prime, has a relative maximum. So let's review for finding a maxima or a minimum. Because when f prime is greater than 0, then f is increasing. And when f prime is smaller than 0, f is decreasing. So based on the problem, we have to find a maxima, which is increasing then decreasing. So we should find a point which f changes from positive to negative at the point. So based on the graph, we found that at x equals -3 and at x equals 4, the graph changes from positive to negative. And that's it for part A. Part B, for -5 to 5, find out which graph of f has a point of inflection. So let's review for finding inflection. The inflection point happens when the graph of f prime changes sign. For example, at x equals 4, f prime changes from when x equals -4, the graph of f prime changes from increasing to decreasing, and that's a point of inflection. And also at point x equals 2, where the graph changes from increasing to decreasing, that's also a point of inflection. Also, there's a point which the graph of f prime changes from decreasing to increasing is at x equals -1, changes from decreasing to increasing, and that's also a inflection point. For part C, find all integrals on which a graph of f is concave up and also has positive slope. So concavity depends on the f-second derivative. And since we know the graph of the first derivative, we know when f prime is greater than 0, then it's concave up. And f second prime is smaller than 0, is concave down. And also the graph of f prime is increasing and f prime for f double prime is smaller than 0, is decreasing. So be careful, I just made a mistake. If the second derivative is greater than 0, it means concave up and f prime is greater than 0, and otherwise f prime is smaller than 0. And when the graph of f has a positive slope, that means the graph of f prime is increasing. And if it's a negative slope, then f prime is decreasing. So we're looking for, in this case, where the f prime is greater than 0, and also increasing. So let's look at the graph. That graph from -5 to -4, and from 1 to 2 is where the graph is both increasing and greater than 0. Okay, let's move on to the final question. So part D, find the absolute minimum value of fx over the close the interval. So they mentioned the closed interval, which is a hint of finding absolute minimum, which may happen at the relative minimum, and also the endpoints, which is at x equals -5 and x equals 5. So we have to find the relative minimum. In part A, we did find a relative maximum, and we know that for maximum is when the sign changes from positive to negative, and in the same way, finding a minimum is where the sign changes from negative to positive. So it only occurs at x equals 1. So that is the 3 possible points we find for a absolute minimum. So now we have to find which one is the absolute minimum, and we have to find the y value of each of these points, which we have to use the fundamental theory of calculus. We know that f1 equals 3 and fx equals f1 plus the integral of 1 to x of f prime of x dx. And then we just have to plug in the numbers. For x equals 5, f -5 -5 is f1 3 plus 1 -5 f prime x dx. And we have to figure out the area for this one, and it's a half circle with the radius of 1, which is the area of pi over 2, and that in the same way is a half circle with radius of 2, which is the area is 2 pi, and we got 3 minus pi over 2 plus 2 pi. And for f equals 1 we know it's 3, and for f equals 5 we have to add up that triangle and the area of that triangle, which is, so the base of these triangles 3 times the 2 over 2, which is area of 3, and that triangle has the area of negative a half. So we have 3 plus 3 minus a half, and it's greater than 3, so we figure out that the absolute minimum is 3 at x equals 1, and that's it.